Bismillahirrahmanirrahim. Assalamu alaikum students. Hope you all are fine. I'm your teacher Sabah Shahid, and students, we have started chapter number 11, that is organic chemistry. Today we are going to study diversity and magnitude of organic compounds. Okay beta, let's see. Diversity and magnitude of organic compounds. As you all know that 118 elements are discovered today, but the number of organic compounds containing carbon hydrogen atoms is more than 10 million, and this number is far more than the number of the compounds of all the remaining elements taken together. So the existence for such a large number of organic compounds is due to the following reasons. And what are the reasons for having a large number of organic compounds is, let's see the first reason, that is catenation. Okay students, what do we mean by catenation? How can we define catenation? And what is catenation? So beta, we have to define it. First of all, the ability of the carbon atoms to link with the other carbon atoms to form long chains and larger rings is called catenation. Self-linking property of a carbon atom. So the main reason for the existence of a large number of organic compounds is that the carbon can link with one another by means of the covalent bond to form the long chains or the rings of the carbon atoms. The chains can be the straight or the branched. As you know that carbon is tetravalent and it can form 4 covalent bond by sharing of electrons to complete its octet. So the first property, the first reason for having the large number of the organic compounds is that the self-linking property of the carbon atom, and that is called catenation. That carbon atom link with other carbon atoms and it forms long rings or long chains, and this property is called catenation. Okay beta, next is, what are the basic conditions for an element to exhibit a catenation? First condition is, element should have the valency of 2 or greater than 2. First possibility. Second possibility, bonds made by an element with its own atom should be stronger than the bonds made by the elements of the other atom, especially oxygen. Okay students, first of all we will explain the first possibility. How catenation, how carbon exhibit the property catenation, how first condition is fulfilled by the carbon atoms. As you know, carbon is tetravalent. It has the valency more than 2. So it exhibits the property catenation. So first condition is fulfilled. Second condition is, bond made by the elements with its own atom should be stronger than the bonds made by the elements of the other atom, especially oxygen. As you know, carbon-carbon bond is more stronger as compared to carbon-oxygen bond. So it also fulfilled the second condition, that carbon exhibit the property catenation. Let's have an example so you have more clear vision about catenation. What is the example? Both the silicon and carbon have the similar electronic configuration, but carbon shows catenation while the silicon does not. It is mainly due to the reason that carbon-carbon bonds are much stronger bonds and having the energy 355 kilojoule per mole than the silicon-silicon bond, that is about 200 kilojoule per mole bonds. On the other hand, silicon-oxygen bond are much stronger than 452 kilojoule per mole of energy, while then the carbon-oxygen bond, that is 351 kilojoule per mole of energy. Hence, silicon occurs in the form of the silica, SiO2, and the silicates in nature. So students, you can see that the second condition is, what is the second condition? That the bonds made by the elements with its own atom should be stronger than the bonds made by the elements of the other atom, especially oxygen. So you can see that carbon-carbon bond is more stronger than carbon-oxygen bond. but silicon oxygen bond is more stronger than silicon silicon bond. So silicon can't exhibit the property that is catenation, because second condition is not fulfilled. So this is the first reason for having the large number of organic compounds, and this property is called catenation. What is catenation? Self-linking property of an atom. Self-linking property of an atom, of the carbon atoms, that is called catenation. Okay students, you can see that carbon can link the other carbon atoms and form the long chains. This is called catenation. Next reason is the isomerism. Another reason for the abundance of the organic compound is the phenomena of the isomerism. How can we define isomerism? The compounds are said to be isomers if they have the same molecular formula but different arrangement of the atoms in the molecules or different structure formula. The compounds are said to be the isomers. Their molecular formula is same, but the structure formula is different due to the difference in the arrangement of the atoms. So that's why their structure formula is different. So this phenomena is called isomerism. Okay students, isomerism also adds the possible numbers of the structure. For example, you have an example. Molecular formula of C5H12 can be represented by the different structures. For example, N-pentane, isopentane and neopentane. Students, you can see that all the three structures have the similar molecular formula, that is C5 and H12, while the arrangement of the atoms will give the three possible isomers. Number 1 is called the N-pentane, number 2 isopentane, and number 3 is neopentane. It is different due to difference in the arrangement of the atoms in that molecule. So this is called isomers of C5H12, that is called pentane. So the phenomena is called isomerism, right? Okay students, next, number of isomers increase with increase in the carbon atoms in the given molecular formula. Clear? Number of isomers, you can make the possible isomers if the carbon number is increases, which is given in the molecular formula. Next is the strength of the covalent bond of the carbon atom. Okay students, you can see that due to the small size of the carbon atom, it can form the strong covalent bond with the other carbon atoms. You can see that the carbon-carbon bond is very much stronger. It can also form a bond with the hydrogen, oxygen, nitrogen, halogens, and this enables it to form a large number of compounds, right? So it is the basis for the strength of the covalent bond of the carbon atom, because carbon is the tetravalent and it complete octet by sharing of electrons, right? Sharing of electrons, the bond will be the covalent in nature. Clear this point? Okay students, next is the multiple bonding. In order to satisfy its tetravalency, carbon can make the multiple bonds, double and the triple bonds, unsaturated hydrocarbon atoms, and this further adds to the possible number of structures. For example, 2 carbon in ethane, that is a single bonded carbon structures, that is saturated hydrocarbons, that are called alkanes, and we have discussed ethane. The ethane are linked by the single covalent bond by a double covalent bond in ethylene. Ethylene and acetylene are insaturated in ethylene. We can also call it as ethene. It has double bond, while in acetylene, which is also called as ethine, it has triple covalent bond. So carbon satisfy its tetravalency by forming double and the triple covalent bonds. You can see first the ethane, that is a single covalent bonded carbon atom, and in the second you can see that ethene, that is also called as ethylene, and number 3 you can see that at the bottom, that is acetylene or ethylene. So ethene and acetylene have double and the triple covalent bonds, while in ethane it has only single covalent bond. Saturated hydrocarbons are called alkanes, and we have discussed an example, that is ethane, while the unsaturated hydrocarbons exhibit double and the triple covalent bond. Like in ethene, it has double covalent bond and it is called alkene, while in triple covalent bond, that is an acetylene, which is also called as ethyne, and its structure is showing on your screen. Okay students, I hope you can understand all the headings of the topic diversity and magnitude of the carbon atoms or the organic compounds. You have to learn this topic. Okay, thank you.